la. Oh, hi there. You like my new shoes? Stat World! And that's my dog. He's asleep. His name is Mathematics. Shh, don't wake the doggy. All right, so we've got one more practice problem to do this week on t-tests. So grab the page and let's run through it. Ready, set, go. All right. An agricultural field trial compares the yield of 2 varieties of tomatoes for commercial use. Researchers randomly select 10 variety A and 10 variety B tomato plants. Is that annoying that I'm saying tomato? Then the researchers divide in half. Okay, got it. And then they compare it. Okay, so they're doing what's called a matched pair. No, it's not matched pair. So they're doing A minus B, and they get their sample, and they get their sample standard deviation. The graph looks roughly symmetric. That's good. Okay, is there convincing evidence? So there's that keyword that's letting us know we have our magnifying glasses, and we're going to find some evidence, aka a p-value, to see if this x bar that we got is significant or not. Okay, so let's define it. We are trying to figure out the true mean yield. And it looks like we're doing variety A minus variety B. All right, okay. Our null hypothesis would be that our mean yield difference is as it usually is, meaning 0, right? There's no difference. I'm going to put in little quotes here. There's no difference. Nothing to see here. There's no difference. But alternatively, we're looking for evidence that variety A has the higher mean yield. Okay, so if A is higher, if this is the bigger number and you're subtracting them, that means you're always going to be greater than 0. All right, we're not going to dip down into the negatives because this number is bigger. So we would say our mean difference is greater than 0. Let's see, true mean difference in yield. I'm going to add that word in there that we're doing a difference. Okay, so and then I'll put in little quotes here. A is higher. All right, they do want us to use an alpha level 0.05, so that's nice. Next thing we got to run through is our conditions. Make sure everything's good. Okay, so did they randomly select their tomato plants? Let's see. Oh, sure did. They randomly selected it, so random has been stated. Check. All right, the next thing we need to make sure we're dealing with is a normal distribution. Okay. Doesn't say, hi, I'm normal. And we only had a sample of 10. Sample of 10, that's not enough for the central limit theorem. However, they did tell us that the graph is roughly symmetric, single peaked, and no outliers. So it is safe to proceed, right? So if we're down here in normal, we could say stated that the distribution is symmetric with no outliers. All right, so we are good to go there. And then the third thing, independence. This one's easy, right? You could talk about having enough tomato plants, but in this case, I feel like each tomato plant is independent from the next, right? It's not going to influence each other. So independent. It's not like you're surveying people where you might actually ask them the same question twice. So for this one, we could say each plant independent from the next. All right, so our conditions are good. There's no red flags, nothing to be worried about. All right, so it's time to get into our formula work. All right, we are running a t-test here. Why is it a t-test? Well, it's because we don't know the population standard deviation. All we have is the sample standard deviation. So because we're running off of samples, we are estimating what this curve looks like. All right, and there's many different types of t-curves. There's only one z-curve, but anywho, t-curve. Here we go. We want to know what that test statistic is. Where are we on our curve? Our sample was 0.34, and we want to know how far away that is from 0, right? No difference. Standard deviation, they said, was 0.83. But we need to adjust it for stats diet. We had a sample size of 10. All right. At this point, I'm going to have my calculator finish it for me. Degrees of freedom, I guess I could squeeze that in real quick. We're on the 9th t-curve. All right. Okay, so calculator, stat world. Run over to test. T-test is number 2. We've got the stats to put in. All right, so our null hypothesis is that there's no difference between tomato A and tomato B. The sample had a difference of 0.34. The standard deviation is 0.83. We're looking for evidence that it's greater than 0, so make sure that matches. Yep, looks good. And then calculate. So our test statistic, right, our t-score is 2.0068, so I'll just say 2. So on a Billy Bell curve, wee, woo, where 0 is in the middle and 1, 2, 3, my baby don't mess around. All right, so we're gonna go over here to 2. All right, so the area under the curve, that is our p-value. That's where our evidence is. And according to old T.I. Joe here, our p-value is 0.028. I'm gonna go ahead and round it to 0.03. All right, so that p-value is 0.03. All right, so now we conclude, is our p-value 0.03 smaller than that cut score that we declared at the beginning, 0.05? Yes, 3% is smaller than 5%. Yes. So if it is small, right, if the p is low, reject the hoe. So we would reject the null hypothesis. All right, conclusion time. We have the evidence. So we would say we have sufficient evidence at alpha equals 0.05, right? You want to let the reader know what level of significance you used. Okay, so we have sufficient evidence that alpha equals 0.05 to conclude. And here's where you don't have to get creative, steal the language, right? This is what we're concluding, right? We found the evidence that variety A has the higher mean yield. To conclude, variety A has the higher mean yield. All right. So it looks like they're going to be growing variety A instead of variety B. Make some money. Well, there you go, my dears. Next week, we will learn one more formula, and then you're done. And it'll be time to start reviewing for that AP exam. All right, enjoy your weekend.